Hello everyone and welcome to the fourth episode of the Threat Hunting with VirusTotal quarterly session. I'm Alexandra Martin, part of VirusTotal's customer success team, and today I'm going to introduce to you the new VT netloc feature, and we will see some use cases and how I work with these new features around Yara. I attached the slides to Webhook so that you can check everything by yourself after the session. And please remember to write down any doubt that may arise during this session, because at the end we have Q&A section with a special guest, my teammate Francisco Perdomo, aka Pancho, who is a security engineer at VirusTotal. And I guess we are ready to go. So, for the introduction, and although many of you are already familiar with Yara, I will provide some quick background context. Yara is like a security industry standard, so many organizations facing information security challenges use it. It was created by Victor Manuel Alvarez, one of our senior software engineers at VirusTotal, to deploy detection or classification rules that can be run locally or remotely over a set of files. Over time, VT's Yara evolved from rules based primarily on text and binary patterns on files to something more sophisticated. We created the VT module for Yara that works over files in the VirusTotal dataset, which includes two main attributes, which are metadata and behavior. And both of them are related to extra data that only can be found in VirusTotal reports. This way, for instance, metadata has attributes for file submissions, such as when, how many times, or from where they were submitted to VirusTotal, and AV vendor verdicts, among other characteristics. While, on the other hand, behavior attributes are directly related to files detonation in our sandboxes, including, for instance, network communication or processes related checks, and much more. And the latest improvement is Yara netloc that I will describe in next slide. Apart from this, just remember that Yara rules in VT can be executed in the past over already existing files, which is Retrohand, and also in the future, like feeds over new samples submitted to VirusTotal or samples that are rescanned, which is the live hand service. Let's see what Yara netloc is. Yara netloc is implemented in the VT module for Yara. It extends Yara supported entities from traditional files to network infrastructure, which includes URLs, domains, and IP addresses. This way, now we can use the same standard to trigger not only malicious files, but also the infrastructure used in threat campaigns. And what for me is highly relevant and very useful is that with netloc, now we can specify relationships between IOCs, which simplifies the way of getting indicators whose related IOCs meet some conditions. So now, instead of performing a VT intelligence search, then for each IOC returned by this query, check out their related indicators and filter only by those meeting some conditions, right? Instead of performing all those steps and using several VT features, including API automation scripts, we can now use netloc, which already includes attributes for the most, let's say, relevant characteristics, to specify all those conditions in one single rule. We will see some example in the use cases. We also started a new initiative to benefit the entire community, which is the crowdsourced Yara GitHub repository, where we encourage the communities to submit their Yara rules and share them with the rest of the community, helping each other to protect ourselves and our organizations. And maybe you have already seen that Lately, we have been very active around Yara because we have published several posts related to it, such as a dedicated netloc post, another one showing how to translate from Sigma rules to Yara rules when possible, right? And we also launched the final Yara editor, which includes a Yara playground, rule templates, and this new IOC attribute structure that makes rules deployment tasks even easier. Now let's go for the demo. And I'm going to start with some rules for monitoring organization infrastructure. In these use cases, the goal is to check if our organization's infrastructure is used in malicious activities or abused in any way, or even misclassified as malicious by AV vendors. Although this last goal doesn't necessarily imply a security risk, it may lead to customer service access loss or reputation damage, so it's important too. So the first use case is focused on legitimate domains that have been misclassified as malicious. Okay, now I am starting by checking VT Intelligence results based on this query here. Okay. It gives me domain entity IOCs classified as malicious by at least one AV vendor and whose name matches this regular expression here, which refers to Santander domains and subdomains with all TLDs. Now checking the results. For instance, this one is clearly a true positive based on these categories here from these vendors and also the subject of its HTTPS certificate. But for instance here we can see that we have to deal also with false positive. This is a phishing domain mimicking Santander's domain, like here. So this is not a legit domain. Now, to eliminate those false positives, you could create a list of your known domains and monitor only those ones. Although I wouldn't use that approach because I want to be aware of everything my organization is launching, even though I'm not notified of those new assets. Now let's see how to create the related Yara rule. To do so, we have to go here to Retrohand. And here we have to check this new rule set to get domains option. And this is the Yara editor. Here we have an example of a rule, and it has autocomplete capabilities like this, for instance. And it shows all the possible attributes that could be used. It has also Yara playground here. In the first tab, you have to put the domains you want to test the rule against. The next tab shows the domains matching the rules and also those that don't. And the last one indicates rules issues. Now here we have rule templates that you can filter for specific interests, like for instance infrastructure. If you put here infrastructure, it automatically filters the results, and you can use any of these templates to create your own rule just by clicking on this add button. And here we have the Yara rule based on that template. Then here we have the structure. This is a new feature, And if you put here a domain like this one, it will show you all the attributes available for this specific domain. And if you click on any of them, let's check, for instance, this one, it will automatically create a rule based on the condition that you checked. But now let's go for our use case. So in this case, I will remove all of these and put here the PT intelligence search so that I can remember what I have to do, and then remove these examples here. Now, based on this search here, what I want to check is the detection ratio of the domain and its name. And in this example, here we already have the detection ratio, right? We just have to change it to 1. And for the domain name, we can use this one, but just change it to match a regular expression. Which could be this one, the same one. Although another option is to use the root domain. To do so, we can go, for instance, to check the structure of this domain, because it works, right? And get here these attributes. Right, now we have root, and remove this to only check the root domain. Let's remove this, and let's remove also this condition, because I'm not interested only in new domains, but also the previous one that have changed the detection ratio. So okay, then what I would like to do is to put the author and the description. And also change the rule name. And the rule set name. Okay, and for testing it, we can use, for instance, this domain. And maybe this other one. Test it, and it works. Now we can save the rule. And it will automatically show up here. If we filter by my rule sets, this is the new one. Okay. Now let's see the next use case. Now, the second use case is about URLs serving malicious content. And this is the with intelligence search. The only way we can refer to downloaded malware from an URL entity search modifier is with this response positive search modifier that refers to file verdicts. But there's no way, for instance, to specify the kind of the downloaded malware via with intelligence, although it is possible via netloc. So we will see that. So let's create a new live hand rule here, and this time let's check for URLs. Again, to not forget what we have to do, let's put this here, and let's go ahead with these rules. So first we want to check the root domain, and we can just change it here to Dropbox. Again, let's remove this condition because we want all URLs, not just the new ones. And let's get the downloaded files. So we can put here serve and let's add, for instance, this one. In this case, they are referring to the file hash, but we are more interested in analysis stats dot malicious greater or equal to 5 detections. Now, how can we convert these to trigger for those downloaded files that are, for instance, related to ransomware campaigns? To do so, we need to add here for any engine and signature invt.net.url.downloaded file .signatures, and let's check all of them. Then check if the signature contains the ransom keyword. So this way we are checking for AV vendor verdicts to see if any of them has identified the file as a ransomware sample. Okay, next steps, as always, let's put the metadata. And here the description, which is very important. And let's change the role name. And the roster name. Now for testing, we can use any of these samples here, any of these Yaras here, but probably they will not match the rule because we cannot easily check if they are serving ransomware or not. But the rule is okay, so we can save it. Now let's see the third use case. So the third use case is about IP addresses, and it combines like all the previous use cases that we've seen. In this case, we are checking IP addresses by their ASN number related to Bank of America. And we are also checking if the IP addresses are detected as malicious by at least one AV vendors, if they are downloading malicious files, or if malicious files are contacting them. So again, let's go to Retrohand. Let's copy this. Then let's create a new IP rule, and let's put here our VT Intelligence search. Then from the rule that we already have here, we can use this part. This can be removed, and here we have to change this by a new one, or communicating files max detections. For this we have vt.net.ip.communicating file dot analysis stats dot malicious greater or equal to 5, or downloaded file max detection 5 vt.net ip downloaded file analysis that's malicious again equal 5. Okay, we have this part done, and we now have to check the ASN. So for that we can grab any IP address from here, put it in the structure, and check its ASN data, which is here. Just grab this, use it here, and now we have the rule. Let's remove this. And now let's check by that IP address. There's the rule. Okay, this one doesn't work, but let's add some more. Even though the rule is okay, we have no issues with the rule. But okay, it works. Now, let's put the author and the description. let's change also the name. ASN and the rule set name. And now we can save the rule. Okay, now using the ASN is not the only way to represent IP addresses in Yara rule in netloc. We can do the same with AP ranges and also with lists of IP addresses strings. To do so, let's add additional data for our rule. Like for instance, we can track this specific range, and let's create a rule with several IP addresses from this other range. For instance, this one. And let's grab also, I don't know, this other one. Okay, perfect. Now, let's first check the list of IP addresses. To do that, we have to put here for any IP in the list, check if the vt.net.ip.raw is equal to my IP. I mix everything together. Let's run the test. No problems here. And the other way related to API ranges, we can check here for ranges. Let's try this one. And this is how AP ranges are referenced in netloc. We can use the helper to get our specific range with these numbers that are identifying the top and the bottom of the API range. So to get that, let's use the reference. We can also use the console to run this JSON script. Copy it, put here, remove one of the examples, and use your own AP range. Like this, run, and use this not really as it is. Because if you can see it here, it's not referring to AP addresses entities. This is for files. So instead of metadata and in the wild attributes, we have to put here net.ip, and the same here, net.ip. Okay, and it will be this or the other one. and let's mix it with the other conditions like this. Okay, now let's run the test again. Okay, it works. And now let's change the name. Range. I paste variable list, and here just change also the reset name, and let's save the rule. And now here are all our new roles. Oh, there's something that I didn't remove, this one. Okay, done. Perfect. Now let's go back to the presentation. And here you have these examples that we already seen, and this slide shows you how to calculate API ranges numbers using Python for those that are more comfortable using Python instead of JavaScript. And the next use case is about phishing campaigns. One of the main use cases in VT that allows organizations to see the extent of the campaigns that are targeting them is the phishing related use case. I will first check the current state in VirusTotal Intelligence, and this way I can figure out the best approach for my monitoring rule. In this first phishing example, we are searching for URLs that are detected as malicious by at least 3 AV vendors with title ENG login and first submitted to VirusTotal in the last 30 days. Now we can see that we have some results, right? But none of them is using the ENG favicon, although we do have an interesting favicon here, this one, and if we check its domain, its related domain, we can see that it has several malicious URLs, right? But based on the details here and this engine, this is a government legal domain, so maybe they were hacked and attackers use the infrastructure to perform these phishing campaigns. Now let's make the rule less restrictive by just removing this login, and let's see what we have. Okay, so in this case we have more results, more URLs, but we have to deal with false positives, such, for instance, this one. Let me show you. Okay, this has nothing to do with ENG, and in fact, if we go to the content and search for ENG, none of the matching strings here are really related to the ENG bank. Now let's see the other VT intelligence search that I've prepared, which is more restrictive with these content restrictions here. And again, we have more or less the same results as in the first example. So yeah, I would say that the first example and this one are the best options for our rule, our Yara rule. Now, something that I wouldn't want is to receive notifications related to rescanned URLs, and maybe better than that, I am interested only in those new domains that are created specifically for targeting my organization, and I would also filter out my legit domains. This relationship logic cannot be implemented in VirusTotal Intelligence, but Yara netloc has the attributes for it, so let's see how would be that rule. So in the string sections, I declare the same strings as in my VT Intelligence searches, and then for the conditions, I restricted them only to VTNet URL and VTNet domain attributes. The first condition is ensuring that I will receive notification only for new URLs that are submitted to VirusTotal. The second one is filtering out all the URLs under the legit domain, right, based on the domain root. Then the third condition is checking that the domain is a new one based on its whois creation date. That has to be this month, August 2023. The next condition has to be that the HTML title of this URL contains eng login as in the first with intelligence search, or if not, it has to contain in the content of the file that the URL is serving, it has to contain 3 of these 4 strings that I've declared here. This is mandatory, this other is mandatory as well, and mandatory as well, one of these 2 here. So I deployed this rule on the 19th, and on the 20th I received 2 notifications. At that time, any AV vendor detected these URLs as malicious, although they are the same, right? The only difference is the protocol. They have the same favicon, which is the eng favicon, and 0 detections. I then checked the URL, and yep, it was not detected by then, and so I checked it outside VirusTotal, and I detected that it was a phishing campaign. It was in German, as you can see here, so I had to use the Google Translator to get the content in English, and then I could see that everything pointed to the authentication form, even the the economic blog link here. Everything pointed to the same login form. Then some hours later, some AV vendors started to detect it as malicious. Next use case is related to the supply chain attack, specifically on Python repository. In June, Alexei Fish published the results of an investigation into malicious packages published by attackers in the Python repository. In this study, he used samples submitted to VirusTotal from late 2022. Apparently, attackers were in general poisoning well-known legitimate Python libraries and re-uploading them, leveraging typo squatting, although there were also completely fake packages consisting only of malicious code. The main target for these attacks appears to be the victim's environment data with focus on browser's cookies. Although, in some cases, malicious libraries implemented original features like hijacking crypto wallet addresses in the victim's clipboard in this case. So now let's see how to track these new packages submitted to the Python repository. In fact, there are 2 ways to do it, and it depends on the purpose behind this tracking activity. For instance, let's say that we have 2 teams. One of them is in charge of updating network communication countermeasures, And the other one is performing reverse analysis over Python malware packages. So the first team would be probably more interested in getting URLs hosting malware, while the second team would like to check and investigate directly samples reports in VT. And with this example, what I am trying to show you is that you can translate Yara rules to get other entities apart from the original ones. And here we have the first rule, which targets URLs, so this is perfect for the first team. In this case, we are mixing both VTNet URL and VTNet domain attributes in the same rule. The first condition is ensuring that I will receive notifications only with new URL that are submitted to VirusTotal. The second one checks that the domain is the same as the Python repository one. And the last one checks that the served files or downloaded files from these URLs has to be detected as malicious by at least 2 AV vendors. Now, how do I translate these to get files instead of URLs? And this is the answer. In this case, we are targeting files, as you can see here, and we are using only the metadata attribute. The first condition is ensuring that I will receive notification only for those new files that are submitted to VirusTotal. Then the second one checks that file have been seen in the wild served by the Python repository domain. And the last one is checking that the file is detected as malicious by at least 2 AV vendors. And this way we have translated the rule that was targeting or tracking URLs serving malicious Python packages to a rule targeting directly the malicious packages per se. Next use cases are about stealers taking advantage of Telegram and Discord infrastructure to exfiltrate data, and the first one is about Telegram. A few months ago, I saw a new report about Sarasa bot, an info stealer that uses the Telegram platform to exfiltrate stolen information from its victims, and this is not something new, right? It's pretty common. Another example from a few years ago is, for instance, Agent Tesla, which also started to use Telegram as C2. Then, using this kind of well-known technologies like Telegram or Discord, attackers have an advantage in bypassing detection technologies. Because of this, I thought it could be interesting, why not, to check new Telegram bots that are used by stealers to exfiltrate data, basically inspired by these network communication logs that I found on one of the Sarasa samples in VirusTotal behavior report. And this is the rule. As you can see, we are targeting again URLs, and this time you are using only the VTNet URL attributes. The first condition is checking the URL in canonical format to point to the Telegram API domain. Then the second and the fourth condition are checking the send message and the send document endpoints of the bot. And for both of them, it also checks the chat ID parameter, which is required, while the text parameter is checked only for send message endpoint. Then, the next condition checks for malicious files that are communicating with our URL and detected as malicious by at least 6 AV vendors. And the last one is checking the AV vendor verdicts to include the steal or the exfilled key strings. Now, if you check the Telegram API documentation, it supports both get and post method with these 4 ways of passing parameters in both API requests. So, in this case, in order to To reduce the number of false negatives, we should remove these checks here, getting the next condition section rule, this one. Now I can track all those bots and even report them to the Telegram support team. Now let's see another example, this time focusing on the Discord webhooks that are frequently used to exfiltrate stolen data. One of the newest samples, called Ver, was detected by the CyberArk Labs team, and apparently this sample pretended to be a stealer builder that tricks victims, making them think that they are building a new stealer, meanwhile they are being compromised. It is attributed to a new group called Kurdistan 4455, and it is composed of two known tools for obfuscation and the main info stealer and exfiltration functionality, plus a custom module for the masquerading part. In this image here, we can see an example of how webhooks are sending messages in the VT behavior report of a sample, and with this in mind, we can deploy the next rule. This is pretty similar to the Telegram bot rule, so it has the same conditions. The only difference here is that it points to the Discord API webhooks endpoints. And now we are going for the Q&A with Pancho. Pancho?
I'm here.
Hi. I'm so happy to have you here.
Happy to be here as well. Should we start with the questions?
Yeah, go ahead. Yeah.
Okay. The first one, there are several questions in the same one. What's the added value of creating Yara rules every time while IOCs can be seized and removed and new IOCs can be created? And should we create Yara rules for new IOCs? Well, the idea is that Yara rules should be more broad and not very specific, like for just one IOC. The idea is to use Yara rules to find patterns or like behaviors, specific behaviors, and not just for finding one IOC in particular. It's when you get better at writing Yara rules, you find like the patterns better, and you don't have to rewrite to find new IOCs in the middle. The other question with this is there any possibility to create Yara rules following the Mitre matrix? Yes, there is. I think I have seen a lot of blogs about using Yara rules to specific parts of the Mitre matrix. For example, data exfiltration via Telegram bots, to say it like that. You can search specifically for the behavior of contacting two URLs of Telegram. That could be a Yara rule that we use in the example previously that is for a specific technique in the matrix. Want to read the next one?
And I would want to highlight that, the value of using these kind of rules, because we have like the perfect example, this example of ENG phishing campaign that was really new. It was a really new one. Nobody was detecting it, but with a simple rule, a simple Yara rule, we could do it. So yeah, it really has a lot of impact, and it's very useful. And okay, then I will go with the next one. Okay, is there somewhere a cheat sheet that explains which condition Yara syntax aligns with which VT modifier? This is related to the VT intelligence modifiers. So as far as I know, we don't have such a cheat sheet, but I'm writing it. I already wrote it down for a new task, right? Because we are already working on something related to Yara, like a cheat sheet only for Yara and specifically for netloc, but we didn't think about to put everything together and allow you like to easily change or switch from VT intelligence to Yara. and do these kind of tasks. So note it down.
Okay. Let me see here. Okay. Out of these webinars, are you doing some learnings, trainings for the same topics? Yes, this threat hunt series is quarterly. So this is the 4th edition. So we have other 3. And well, we also have the blogs that are posted in our site. And if you refer to something different, please contact us or ask another question for that. You can contact us.
Yep, and we have lots of documentation in our webpage that you can check. I think we are very active on internet. I mean, online with new findings and things like that. So yeah, we have a lot of documentation. So, but if this is regarding something else, please don't hesitate to contact us, and we will be happy to help you. Okay, the next one, can I get the structure output without going into the Yara rule builder? Well, we don't really have the specific, the endpoint for this specific structure, but you can get the same information from the IOC's report, right? Because at the end, what we are showing you are is the information like the static and the dynamic information about the IOS that we analyze in our dataset. So I know it's not the same because it's not really the same structure and it's not the same, but at the end you can find the same information.
Is
Okay.
there any possibility to create regex for typo squatting detections of the name of the organization that we want to monitor? That's something that we have on the roadmap, that functionality in particular, to be added in Yara as an option, as we already have it in BT Intelligence, but not using a regex. You were commenting me, Alex, that there's another approach to this, right?
Yeah, better approach is to use for instance, the level standing instance. It's easiest to use this instead of regex. I don't feel that that could work well, but I don't know. I should double check it just in case. But right now we don't have we have anything about that specific regex for type of scouting.
Perfect. Where can we find the 2 rules Alexandra just showed in Discord and Telegram? The presentation will be shared with you. It's already in the announcements. There's a link for that, so you can check it on the. It is the rule is in the presentation. Yeah, you can see it
Yep.
there.
And in fact, you can just copy and paste them. So.
Mm-hmm. Let me.
And also, we are
update it.
submitting this session. We are submitting it also to our YouTube channel. So, if you prefer to use YouTube, you can do that.
I'm cleaning the questions that we already.
Okay. Can these Yara rules be created to block spam emails? Yes, of course. It depends on your imagination, right? And the time that you have in order to research and get the correct, let's say, ways to find those emails. But yeah, definitely you can do that. In fact, I will add something else here. You can automate these like this task, because let's say everything that you are notified about in VirusTotal can be automatically triggered with the VirusTotal API, and you can automate that flow, right? So it's very easy.
Are the previous parts 1 to 3 available to view? I think they are. They are right in
Yep, yeah, they are
BrightTalk.
already in YouTube and
And
BrightTalk. Yep.
perfect. Mm, okay, very simple.
Which is the needed subscription to do this? I lost the question. Okay, enterprise subscription is okay. Yeah, I think it's okay because this is like another is the normal Yara model, but it's just enhanced. So yeah, with the enterprise subscription, you will be okay to use netloc.
Okay, I'm marking it. Is there a mapping showing all the web search terms equivalent to Yara terms and vice versa? I think there's no direct match. I understand that this question is a match between BT intelligence and Yara rule. There's nothing. There's nothing yet that is a direct translation between the intelligence and Yara. It could be interesting, but not for now. We don't have a matching right now.
Although if we create that kind of documentation, we will definitely post it on the VirusTotal blog post, so you will find it there.
Mm-hmm. Can you explain how you come up with infections rated to 1 versus infected rated to 5 in your rules? I don't understand the question exactly. Is how do you find them or
No,
no?
I believe it's more related with why do you, or yeah, why do you decide to use those specific numbers? So, for instance, the infection greater than 1 is for hunting, let's say. So you are not, I mean, maybe there are new files or new URLs or whatever that are not being detected by now. So in those cases, the detection ratio is very low. So this is more used for hunting, right? While the other one is, let's say, to get all the samples that you already know that become for that are of, for instance, a certain campaign. You can grab all of them or a few of them and investigate further on that specific campaign. But it's depending on the kind of goal that you have. If you want to get and fight with false positives, you can use the 1 or 2 or like a low number. But if you want to make sure that you are targeting malicious, like very malicious files, then you can use more like higher numbers for detection ratio.
Perfect. I have one in the top. What's the difference between live hand and retrohand? Live hand, retrohand searches to the back, like for historic examples. There's a limit on how much it searches to the back, but that's the idea. Live hand is when you create the rule, it starts searching from this moment on forward, everything that is reanalyzed or uploaded or something like that. That's the idea of live hand, and retrohand is for the back. Do you know the limits of the retrohand, Alex?
The limit of Retrohand is a year of submitted files, like those files that have been submitted during the last year.
Mm-hmm.
And yeah, what I would also add here is that, for instance, Retrohand is very useful for investigating something that already have occurred, while live hand, or to prepare your rules, for instance, is very useful for that, while live hand is more related to feeds, right, to be notified anytime something happens. And yeah.
Yeah. How do you guys import IOCs to security devices that you cater through these rules? This one I will need a little bit of help, but you have the notifications. If you create a live hand, you have notifications that you can get. I don't remember exactly if you get all the information in the notifications for that. That's where I need the help, Alex. But
I don't understand the question, sorry.
I imagine it is, I create a rule, a Yara rule, and I apply it on LiveHand, and I want that to be a feed of information for my CM or something like that.
Okay.
As far as I understand, that is very possible
Yeah, with
option.
the API is definitely possible, and we also have, um, well, but that's for enrichment. Yeah, if you want to apply Yara rules, then use the API and LiveHunt.
Yeah, I was thinking on that. Uh, yeah, yeah, sure. If you are polling on the live hand detections, for example, you could automate some part of the information feed that you get from what you search. The one for spam emails you already answered.
Yeah, I think so. So I will remove it from here. Okay.
Okay, does Yara work
That's
with
it.
Suricata rules? I'm not sure about that. I think that the syntax is not the same, right?
No.
I'm not that familiar with Suricata rules, so I can't answer you properly with this question. We can search, but it's
Yeah,
not easy
I
to
think the
find.
language are different, but I believe that you can translate the Suricata rules to Yara, as we already demonstrated with Sigma rules. I mean, maybe there are specific cases when you cannot like create the coding Yara rule, but normally I would say it's possible to translate it, but it's not work. I mean, they are not working the same.
Okay. Google has an AI language model. Any plans to allow BT Yara developed via that mechanism? ChatGPT can do this, but it's based on outdated data. It could be possible. It depends. Let's think about this. You can, depending on your ability to create Yara rules, you can find better answers or more broad answers. And I assume that depending on your prompting abilities for AI, you could do something interesting with to create better Yara rules. But you have to know what to ask for first, and that could be like the same problem.
Yeah, I think
But
so.
it's something that is possible. Yeah, if AI can make the Yara rules, uh, you can ask the AI to create it, and if it is okay, you can implement it.
Yeah, I mean, you can test it in VirusTotal, so
Yeah.
you can see if it really works or not.
Okay, and here we have some outstanding presentation. Thank you. Glad to
Thanks.
hear that. And this has been really educational. Thanks. Okay. Thank you very much, Alex, for everything. The presentation was great. Yeah.
Thanks to you, Pancho, because you helped me a lot with these questions that, in fact, I really enjoyed. They are very interesting. And if there's something else that you would like to add, please don't hesitate to contact us because, yeah, we are here to help you. And yeah, I think this is it. We really hope you liked the session and you find it useful. And please send us feedback. And also, please remember that if you do have Yara rules, interesting Yara rules that you would like to share with the community, use our crowdsourced Yara GitHub repository because the idea is to help each other with these tasks. And I don't know, Stay safe. See you in the next session. And as always, happy hunting, Pancho.
Happy hunting.
See you. Bye.